All right, guys, welcome to this course. I want to introduce you to this deep reinforcement learning course. It's particularly for finance, like you can see here, and it's 101. I name it 101 because it's a fundamental course. So if you're interested in deep reinforcement learning or you're interested in finance, particularly this course is going to be talking about day trading, right? So we're going to learn how we can trade stocks, forex, commodities, and cryptocurrencies in this course. So we're going to use day trading as our application of deep reinforcement learning. This is a branch. This is the most exciting branch of AI. So guys, if you're excited about AI and you want to use it for day trading or for finance, this is a great place to start. So uh, in this particular video, I'm just going to give you an overview of all of the components of this deep reinforcement learning. Like, it's going to be a quick run through, and I'm going to take some step by steps to in the next couple of videos to give you a detailed understanding of what deep reinforcement learning is and what uh, day trading is in finance, so that if you put these two together, then you can use AI for day trading, and you can build a completely a new model, or in AI we call it an agent, that can make decisions for you during trading, and you probably can make some profit. So this course is presented to you by me, right? It's kind of weird sometimes for me to like pronounce my name, but like, yeah, this is it. If you want to know how to pronounce it, like, hit me up. That's all right. And you can see here Katika AI Education. So this course is brought to you by this is a company, Katika. It's focused on AI, and education is one of the components of the company. And so today I'm just going to introduce you to deep reinforcement learning for day trading. And one of the things I'm going to cover will be so this is the content of this video or of this lecture. It's going to be a quick run through, right? If you're really interested, I'm going to produce some other videos that take the components step by step in a much slower way. So if you're looking for a video just to overview what deep reinforcement learning is and what it can do to day trading or finance, this is your video. So we're going to look at what reinforcement learning is, an introduction, and then we're going to look at the framework of reinforcement learning, like how does reinforcement learning look like, and going to look at the components that make up reinforcement learning. And then we're going to look at the like when we finish looking at what reinforcement learning is, because this is what we want to use to solve our problem. And then we're going to go deep into like the problems that deep reinforcement learning can solve, right? Like, what kind of problems? So probably day trading is one of the problems. So we're going to look at the task that deep reinforcement learning can solve, and then we're going to look at the solution, like how does it go about solving those problems, right? So this doesn't just apply to day trading, it applies to a lot of stuff. And day trading is an example that we are using here, and it's an application. So this is an overview, but it's a direct application. So most of the time you learn AI in a general view. So we're here focusing on like day trading. So when you look at this, you can go and day trade and build a system to day trade. And then we are going to look at the learning process. How does an agent learn, right? Like, what is the process? And then we're going to look at what is the deep in reinforcement learning. So if you look at it, like, reinforcement learning is a type of machine learning, and deep learning is another type of learning. So when we put this together, it gives us deep reinforcement learning. So this synergy of these two learning methods gives us amazing results, and that's what we're going to look at today. So to go ahead, so in reinforcement learning, we have an agent in a market environment. Market environment here is an example because we're doing trading, right? So it could be an environment, a world environment. So we are using market environment because we are using it for trading. It could be stocks, crypto, commodities, FX, and all that, right? So a reinforcement learning in an environment, it learns an optimal strategy. It learns how to trade. It learns a technique of trading by interacting. Like it just goes into the trading environment and interacts with the it tries to trade and makes errors and receive rewards, and it learns without supervision. It learns from its actions. So it's just interacting with the environment and trying to figure out, like, what is the best way to trade to make money, what is the best decision I can make to make money, right? So this is how it learns. So we have an agent in an environment that interacts with that environment and receive some form of rewards. These rewards, so it tries to maximize to get more of these rewards. So these rewards, they are what makes the agent learn how to trade in an environment. A good example is just like, let's take a very naive example, like you have a kid. He's learning how to. He's just playing around the house and he touches a hot pot, and of course he's going to take off his hand from it. And next time he knows he can't touch that pot that is hot, right? So it has learned that it doesn't have to touch a pot that is hot. So it's the same like a reinforcement learning agent. It goes into a trading environment. It makes a decision in a certain time interval because it sees certain movements in the market. And so it learns that, okay, whenever this happens, I don't have to trade. Whenever it happens, I have to trade, right? So that's what it's doing. So to look at the process of reinforcement learning, we can put it this way. We have an agent, right? So first of all, we have an environment. So in this environment produces a state. The state could be like, okay, let's say we are trading on a monthly, let's just say in a month. This is the first day of the month, right? This environment has, let's just say, for example, this environment has the prices, the time frame in 1 year. And then we want to start trading from today. So this environment is going to produce the state today, and our agent is going to decide, okay, what action can we take today to make a profit? So we take an action and then we send it to the environment, and the environment gives us a reward. So if that action was good, it gives us a positive reward. If it was bad, it's going to punish us. So this state, so we go to the next day, the agent acts. We go to the next day, it sends the next day information to the agent, which is the price of the stock or the crypto. And the agent acts, send its action to the environment. The environment gives it a reward. So sometimes we want to make money on a monthly, on a weekly, on a daily, so we can give a reward based on how that agent is acting, right? So at the end of the month, we're going to see like, oh, how much reward did it get? How much profit did it make? And it's going to be like the reward. So we train this agent in order for it to make us like money on a monthly, right? So that's what we're trying to do here. So this is the reinforcement learning framework. You have an environment. The environment produces a state. That state is given to the agent. The agent sees, is like, this is what the agent is seeing now. When it sees that, it decides what action to take. When it takes that action, the environment is going to give it a reward for its action. So if it's a bad action, you get a bad reward. If it's a good action, you get rewarded. You get profit in the trading sense. All right. That's the introduction. That's what reinforcement learning is. So if you have any questions, please just hit me in the comment section. And then let's look at a general, this is a more general view, right? Like just what we explained previously. But now let's say that we have a time frame and we have prices, right? So let's say these are prices of Bitcoin, and we have a time frame of one. So normally we can take this time frame. If we are doing day trading, this is day 1, day 2, day 3, day 4 to day 9, right? And these are the prices that change throughout those days. So this is the price of Bitcoin on day 1, on day 2, on day 3 to day 9, right? So let's say, okay, we have Bitcoin on day 1. We send this price. The state is this Bitcoin. This is an environment. It sends this state 1. So you can see here state ST when T is equal to 1. So we have 22K, right? And then it's going to send this state, the price of Bitcoin is 22K. So you're an agent. What are you going to do? Are you going to buy Bitcoin? Are you going to hold, or are you going to sell, right? So let's say we decide to buy. Okay, we buy, and then we tell this agent, okay, we bought the Bitcoin at step 1 for 22K. So this environment is going to look at the next state, 22K again, right? So what is your reward? You bought Bitcoin. The price didn't go up. It didn't go down. So you didn't lose nothing. So the reward here is 0 because you didn't make any profit. So now we are in state 2, right? T equals to 22K again. So 22K again, we stand here, this 22K here, and here we have the reward, which is 0. So now our input to the agent, we give it the price at T equals to 2. And then also, we also give it the reward that it got. We can decide to give it a reward, or we can decide not to give it a reward, right? That's an option. But these are the inputs to the agent. And then the agent now, the next step, it can decide to make another decision. Am I going to sell or buy? So let's say we sell, right? We sell the Bitcoin, and then it goes to step 3. At step 3, what happens? So at step 3 now, the price of Bitcoin went down and we sold. So if we sold and the price went down, then we made money, right? So we get a positive reward, and it's given here. And then we go to, so because we were in step 2 and the action we did was we sold, and then the next step is 21K. So the next step, this environment now, when we send our action here, it sees the next state and gives us our reward, right? So the next reward now, it gives us, oh, okay, the price went down and we sold, so we made a profit. So it's going to give us a positive reward. So this reward can be decided by, so let's say we made 1K, so it's going to give us 1K reward. And then we're going to move to the next state. So the next state is T3. So notice that the reward here is based on T3, and the next action is T3. So the reward from T3 and the price from T3 are going to be used as input. So we do this for a month, and then we teach this agent how to trade when he sees the price of Bitcoin. So this is just an introduction, and this is how you can think of what a reinforcement learning is. So this agent is trying to learn how to buy and sell Bitcoin in order to make profit, right? By interacting with the prices in the Bitcoin environment, right? And taking actions, which is buying and selling. So this is the way I can put it. So actually, the way we can define reinforcement learning is a framework for solving control tasks, right? So you can see that this is a control task. This agent is trying to control money, the flow of money. You know, it's a control task or a decision, also called decision problem, right? This agent is trying to make decision every time it sees like an observation or price of Bitcoin, right? And then, so we build these agents to learn by interacting in this environment and doing it by trial and error. So at this beginning, this agent is dumb. He's just doing random stuff. He doesn't know what he's doing. And after some time now, we can see that the agent learns actually how to trade, and it can make profit, right? So it frees us from thinking emotional, damage when we are doing, trading and stuff. So this is what our reinforcement learning environment is doing, right? So let's go ahead and let's take a look at the components of reinforcement learning. Reinforcement learning is this, like I explained, is this kind of trial and error learning method, right? So what are the components? What do you need to build a reinforcement learning agent, or what do you need? What are the components that you need for reinforcement learning? First, you need an environment, right? So here we are doing with a trading environment. You've heard of self-driving cars, you've heard of protein, structure prediction. All this can be done with reinforcement learning, but the environment you're learning in is the task that you want to learn. So if you are trading, your environment is a trading environment. If you're learning self-driving car, your environment is probably a road or street or city, right? So this is the environment. So we need an environment, and this environment produces observations, right? Or a state, just like we saw. It produces the trading environment produces the price of the asset that we want to trade. So we need an environment, and that environment will produce a state. So we need these two components, and then we have an agent. This is the the decision maker. We have an agent, and that agent takes actions. So we can see these are one of the, we need an environment that produces a state. We need an agent that takes actions. And when we take an observation, when we have an observation and we take an action, we're going to receive a reward, right? So these are the components of reinforcement learning. We have an environment that produces a state, an agent that takes an action, and based on that action that it takes from the observation it sees, it gets a reward. So these are the five, one, two, three, four, five basic components of reinforcement learning, right? So moving forward, we can, so how do we link these components together? I think we already mentioned this. So we have an environment, it produces an observation and a reward. And then this observational state or reward is given to the agent, and the agent looks at the observation and takes an action, and that action is sent to the environment, and then the environment gives it a new state and a new reward, and then this new state and reward are given to the agent again, and then that loop continues. So we can do this for a long time, and we can repeat this over and over for the same environment in order for our agent to learn. So imagine if you're given 10 lives, right? Imagine in your life today, you live and you die, and that's all. You're not given a second chance, right? But as we grow, we learn and we correct ourselves. And then imagine this: an agent is learning how to trade, it's in an environment, and it has the opportunity to learn more than 100 times. It's like you're living 100 lives. You die and you come back, you die. So it's like a game, right? You're learning how to make better decisions. If you live 100 or 1,000 lives, probably you learn how to make better decisions. But anyway, we are living like like we have evolved from our ancestors, and today we are able to make better decisions and stuff like that. We can say it that way, right? But this agent is the same agent. We can also say it's evolving. It's just in a computational sense, it's evolving its decision making by learning by try and error. So that's how I can put it, right? And then let's move forward to looking at like the reinforcement learning framework, right? Like we've already explained like what this picture says. So this is my own design of what I can use to explain what a reinforcement learning framework is. And then I just want to say that this is not ideal. There are so many other ways of putting this, but yeah, the general framework is you have an environment, a state, an agent, and an action, and you get a reward. So we have state, action, reward. These are the three things that are really important in reinforcement learning. So we have an environment, state, action, reward, and those actions are taken by an agent, right? We've already seen this, right? And so in the reinforcement learning framework, we have a sequence of, at every step, what are we doing? We have a state, right? At that state, an agent takes an action, right? And that action gets a reward from the environment. So when we get a reward from the environment by taking an action, we go to the next state. So that's why we see here in a reinforcement learning, it's a looping sequence, right? So we do this step by step. So in the first step, we have a state and we take an action. That action produces us a reward and a new state. Right? So if you understand my previous explanation, so we have a state. This state makes an agent. So this state makes an agent. Based on this state, an agent takes an action, right? And based on this action, the state gives the agent a reward and then gets to the next state. So we do this all over and all over again till we get to the last state, right? So when we get to the last state, we can get the total number of rewards. So these are all the rewards we get. We can sum these rewards and see, oh, how good was our reward, right? So this is the reinforcement learning sequence. So if you want to train your agent to trade for 30 days, this is going to be 30 days, right? There will be state 0 to state 29. That's 30 days, right? And then you're going to have this loop, 30 actions, right? So think of the sequence like that. So for many cases, trading and all that, you're going to have like, you can trade forever, right? There are states that start from, you can start trading today and end in the year, whatever, infinity. And then so these statements here, they basically explain what the reinforcement learning framework looks like. So this is how we can interpret what the reinforcement, we can break it down like this, right? And then so using this format, we know that the agent's goal is to maximize its cumulative reward, right? What is this? You hear this a lot in reinforcement learning. Cumulative reward, right? Cumulative reward is all the sum of all rewards, right? And it's usually called the expected return. So if we talk about we are doing day trading, right? So cumulative reward is, okay, our first reward is we make profit, we lose money, we make profit, we lose money. So our cumulative reward is the sum of all this. So if you add all this, how much profit did you make and how much money did you lose, then you get your cumulative reward, which is your expected return, right? So just take it as the sum of all these rewards for every state and action that you took, for every action and reward that you got, right? You get a reward. So the goal of the agent is to do what? Is to get better rewards and to make sure that the total number of rewards, it's good, right? So that's the reinforcement learning framework. And then moving forward, so the reinforcement learning framework is built on this reward hypothesis. This is very important in reinforcement learning, reward hypothesis, because the agent only learns because it receives rewards, right? So if you want the agent to act a certain way, then you are going to reward him if he acts that way. So you want the agent to be able to get you profits when day trading. So you're going to reward him when he makes more profit, when the actions that make profit with certain observations are going to be rewarded more. So that's what he's going to be doing, right? So this is the central idea in reinforcement learning. The reward hype, rewarding the agent when he does good actions. And the goal is to maximize the expected return, like I just explained previously, right? So the best behavior, so how this interaction of the agent with the environment, we can define it as a behavior, right? So the best behavior that the agent exhibits, we are going to use that behavior as the behavior that gives the best return. We are going to say, oh, this is the best behavior, and this is what we'll call our model. So we're going to use this model to put in a stock environment and say, okay, bro, like this actions, the way you're behaving is good, man. Go in there and make me some money, right? And the agent is going to die right in there, and it's going to make you that money, right? So let's just say, like we explained before, the components. This is our environment, right? Our environment is, okay, let's just say an environment is this prices in a month, and then a state. So remember, an agent just sees one state at a time. So a state, it's going to see, okay, let's say it's at time t equals to 2, and the agent is going to take an action. Am I going to buy, hold, or sell, right? When it buys, it goes to the next state, t equals to 3, 21,000. Sorry, I made a mistake here. I should probably say 21,000, and this is t equals to 3. Okay, and then the reward. So when it goes to t equals to 3, what is the new price, right? T is equal to 3 is from the environment here. And what is the new price? 21,000. What did you do? You held. If you held, if you didn't sell, then you made money, right? If you sold, then you made money. So sorry, this is probably wrong. So I should reverse this. And then you can see that. So this is just to explain the reward. So the reward here can be positive. So if I take this action, buy, I get plus 20 points. If I take this action, sell, I get negative 20 points. If I just hold, I get 1 point. So what action do you want to take anytime you see 21K? You buy, right? So that's an observation. The complexity of trading is much more than this, but this is just for simplicity. And guys, this is not financial advice. I've heard so many people, whenever they're giving like examples of trading, you have to make this statement. So I have to make it too. Yeah. So don't go out there and trade based on this example out here, guys. Yeah, so then moving forward, let's look at the different components of reinforcement learning. We've already seen the components, so let's look at the components in details, right? So reinforcement learning follows a property. The model of decision making follows what we call Markov decision process. So a Markov decision process is that an agent only sees a current state in order to make a decision, right? That's a Markov property. Like, okay, I'm here. I only decide what I will do tomorrow based on what I see today, based on what's happening today. I'm not going to think of what happened in the past to make a decision about tomorrow. So that's the Markov property, right, of reinforcement learning. And you can see, like, we have an environment. We just take one state. This state is like one day. We give the agent, based on this day, the agent makes a decision, right? So this is the Markov property. So we still keep coming back to this, to this picture, which is a picture that we use to demonstrate what's going on with reinforcement learning. All right. And then, guys, I think you've seen me saying state observation from coming from like the environment. So an environment produces a state or observation. Normally in reinforcement learning, this means the same thing, but sometimes they can be distinguishable. So we distinguish them when it's like, all right, so for a state, it's like, okay, you can see everything at that particular point, right? So for example, if you're playing chess, at a given state, we can say something is a state when we have a state when we can see the whole board. We can see the whole what is happening at that particular time, right? And then an observation, what I can say is that besides the price of Bitcoin at a particular time, there are other things happening that influence this price, right? It's not just we don't make the if you want to really make a good decision, it's not only based on the price. It might also be based on, at this time, maybe this is this day, right? On day 9, maybe there's news, right? There's news about, like, there's some bad news or some good news or something in the headlines on Twitter. So you can also use this. This is an observation. That's another observation. But here we have only one observation, which is the price. We can have so many other observations. So if we have all the observations needed to make this decision, we can call it a state, right? So here we have all the available information needed to make a decision, but here we do not. And probably in this case, we can never have all the information, right? Unless, like, I don't know, like, yeah, that's impossible, right? So if we have all the information, then we can make the best decisions, right? So it's for you, these observations now is for you to choose the best observation that can help you make a decision. Let me put it that way. But the point here was for me to distinguish between a state and an observation. So just take a state, like, you can see everything that's happening at the moment, right? And an observation is like, all right, you can only partially see what is happening. You can't see everything, right? Yeah. So here, let's say we are playing chess and I blindfold this point, right? Let's say we are playing computation and I blindfold this point of the game, right? You can't see what is here, but you can see the rest of the board. So this becomes an observation and not a state. So let's just distinguish it that way. There's arguments, it just depends on, like, how you see it, but that's how I can explain it to you guys. All right. So let's move forward. So this is I want to explain, like, what is a state in an environment, right? So we have an environment, we have a state and an observation. And then let's go forward and look at actions, right? So action is what an agent will do in an environment, right? An action is what I'm going to do in an environment. So what so when you're doing day trading, what are the actions you can take? You can either buy a stock, you can either not buy, or you can sell, right? So these are the things you can do. So this is what we call action. So, and in reinforcement learning, these actions are discrete, right? You can do one thing or the other. So you can do 1, 0, or -1. These are discrete actions. And then we also have continuous actions. Let's say, okay, let me say I want to buy. How many percent of this stock do I want to buy? So those are continuous actions. So at every stage, I'm buying 20% of this. So this can be 0.2. If I say I'm selling 20% of this, this can be like -0.2, right? So we have continuous actions and we have discrete actions. So discrete actions are like, you have an action like maybe you can buy 1, 2, 3, 4, 5 to 10% of a stock. You can convert it into discrete actions. Or if you want to put it continuous, like you can buy 25.2%. Those are continuous actions, right? Yeah. And then moving forward, let's look at the reward, right? What is a reward? Like this is one of the most important things in reinforcement learning, right? So a reward is this is the feedback to the agent on how good its action is, right? So this is very important because this will define the behavior of the agent. So the way you define your reinforcement, you define your reward function is going to define how your agent acts. So if you're going to reward like bad actions, okay, that guy is going to learn how to be very bad. So if you really want to lose money, so just reward him when he loses money. If you want to make money, reward him when he's making money, and he's going to keep making you money. All right, it's not as simple as I'm making it, but like this is how you can interpret it, right? So let's just say a reward is a feedback, right? So let's say we go through a loop, right? Every action, we've already gone through this, and this is just a reflection of this, the reinforcement learning loop. So we buy, sell. These are some actions that I've just made an example of. And then in this loop, so we can see our rewards, right? These are all the rewards we got, right? So at 22K, he bought. At 22K, he sold. He got 1. He lose 1. He got nothing. He got nothing. He lose 1. He got 1. So you lose some, you get some, right? And at the end of the day, the cumulative reward is going to be like, how much total money did he make? So when he gets how much total money he made, he's going to know that, okay, based on this total reward, he's going to know that these actions are good at this stage. So that's how he learns. And he continues to do that. So we can see here, the reward at time t plus 1. So this is the cumulative reward, is the sum. You can see the sum of all the rewards. This is the cumulative reward. So this store here, this is just the trajectory. This trajectory just means these different states, right? This is the different state action reward that it's going on here. And then we have something called the discounted reward, right? So discounted reward is like at different states. This is a little more deeper. So at different states, we discount the reward based on. So for example, at step 1, right? If I get a reward, I just say, okay, I didn't have enough information, so I got a reward. Let me just give you all the reward. So at step 2, I got some more information, but just a little. So I discounted a little bit, right? At step 4, I got more information. So at the last step, you got even more information. So we discount the reward more because you were taking that action with more information, right? So we discount this reward. So this discount reward is the rate at which we discount future reward, right? This is because we want to make, like, sometimes we want to make the reward that you take first more important than future rewards, and sometimes you want to make future rewards more important than rewards that are taken earlier. So we'll wrap our heads around this a little later when we go, if you want to go detailedly into the course. Of course, this is just an overview, and I'm going to go detailedly later. And so moving next, so we still have a reward, right? So this here, we just demonstrate how we can compute the reward. So we have the time. This is a discount. We just get the discount. And if we want to get the cumulative reward, this is just the cumulative reward, right? So if we just say the discount is equal to 1, it means we give the same power of reward to every decision at every state, right? So we just compute the same thing. And so if it's 1, 1 to the 0 is 1, 1 to the 1 is 1, 1 to the 2 is 1. So we just, yeah. So this is the cumulative reward. And we see that our agent, he lost 1 kwai, $1 or 1 unit of his money. So this is just what we can say the reward, explain the reward function to be. But it's if you want to go deeper into reinforcement learning, we're probably gonna do that when we are getting deeper into the course, but not at this point. So, and then reinforcement learning tasks. So there are different tasks that reinforcement learning can add. So there are courses we call there are tasks that we call episodic tasks and tasks that we call continuous tasks. So what are episodic tasks? So try to look at this picture and you can try to figure out what is the difference between an episodic task and a continuous task. Okay, now for example, we are talking about day trading, right? Do you think that is an episodic or a continuous task? Okay, it could be both, right? So let's say you're trading, you're day trading, and you just every month you want to stop trading, right? So you want to trade from 1st to 31st. That trading will be episodic because you only want to trade from the 1st to the 31st, and then you see your profits, and then you stop there. But if you want to trade forever, it's going to be continuous, like it's infinity, it never stops. So an episodic task is one that has a starting point and has an ending point, right? I know where I start and I know where I end. But a continuous task is one that has no beginning and has no end. You can also see this with games, right? Some games are continuous in the sense that you never end. You go to stage 1, stage 2, stage 3, and you keep playing and playing and playing. But some games are episodic in the sense that when you die, you're dead. And so the episode ends when you die, right? When your character dies in the game. So we can call that an episodic state, an episodic task, right? So I hope you understand the difference. So if you want any more details, you can hit me up. Yeah. And then what is the solution framework to reinforcement learning, right? So we've seen like, okay, these are the different tasks. So how do we solve this task? In our case, we are talking about day trading. So how do we solve the day trading task in reinforcement learning? How do we build an agent to make money for us, right? So we come back to this our picture. This picture is very powerful. Like it can simplify a lot of stuff for us, right? So we solve this problem just the same way we explained before, right? We have an environment. Let's just say we are trading for a month. Day 1, we get the price, and then our agent learns to take an action, and we see if we make profit or not. And we train it till the end of the month, and then we see how much money we can make from the cumulative rewards, right? So our agent in reinforcement learning, what we say, the agent is learning to make decisions or to take actions. In reinforcement learning, we call this a policy. The agent is learning a policy. You can hear this in the news, like the government has released a new policy. We cannot send money like this. So this is also what the agent is doing. Is learning a policy. Is learning to make a decision when in this certain situation. So you can also think of it like policymakers in government and like our leaders, like how they make decisions, right? They give policies. So we want to learn a policy that can make us money in the trading environment, right? So our agent in reinforcement learning, we usually say an agent learns a policy, right? And this policy is used to select actions based on observations, right? So we want to learn a policy We want to learn a policy that takes actions that will give us good rewards based on the observations it's made and based on the environment that it's on, right? So this is, we are trying to train an agent's brain, and this brain is the policy for this environment in order to make it make profit for us. So this is what we can say a solution to reinforcement learning, and this applies to so many different environments or applications, right? You can use AI for different applications. What you need to change here is you need to just change the environment. So, and this environment is going to produce you a different state, right? You can have the same agent. It's going to learn a different policy based on its environment, right? And you can change the type of actions that this agent can take. Even in this trading, we just buy wholesale. Like, there are different type of actions that you can decide like this agent can learn to take, right? But you have to define what it can do. And you have to define also the reward function. How do you reward it based on what kind of environment it's in, right? So that's the solution framework. That's the simple way that I can put it in, right? And then still looking at the solution framework, let's say, so in mathematics, like it's really important for us to learn a little bit of maths of this, like for you to really understand. We can say our action is a function of the observation. So let's say that our observation, or like in the previous, like our observation is the price, right? So our action is based on the observation, and our action will, as we give our action, we're going to receive a reward, right? So if you look at here, so a function of the price, this price is the observation. Know that this is not the best example. It could be, you could have price, high, low, trading volume, news sentiment. So the function of the price equals to the action. So for example, if the price is 20K, what am I gonna do? So we can say F of 20K for Bitcoin is what? F of 50K is what? F of 120K is what, right? So our actions are simply taken, we are learning a function. This function learns to take actions. And what is the input to this function? Is the observation, right? So we learn the function that maps these observations to actions. So when we learn this optimal policy, then we've learned an optimal function that when we input our observations, it's going to give us actions, right? So that's what reinforcement learning is, and that's basically what we are trying to do. We are trying to learn a function that produces actions, the best actions. Yeah. So yeah, that's what reinforcement learning basically is. And going forward, let's take there are two approaches, right? Let me just give you an overview. There's two approaches to do this. We have policy-based methods and value-based methods, right? And then I'm not going to go into any details right now because that will be done in the course. You should sign up for it, and if you want private lessons, you can also hit me up. And so policy-based methods, they learn policies directly, right? They learn how to just take actions. I'm just learning how to take actions. And so it learns a policy functions. And then we have value-based methods. So in value-based methods, we try to learn the value of a state, right? We don't try to learn like how to directly take actions. We learn how to move to a valuable state, right? So for example, if we are taking actions, we take an action that will take us to a state that is very valuable, that has the best, that give us the best value. So that's what value-based methods are. That's the way I can explain it. And yeah, probably we'll go into detail that later. And then let's look at policy-based methods, right? So we have policy-based methods that are determined. If you remember, I told you policy-based methods, we just learn how to take actions directly, right? So you have a state, So let's say we have a state and we have actions here, right? These are actions. This is a model that I've designed. So these are states and these are actions. Let's say we observe this state. So this is the price. Let's say the y-axis is the price and the x-axis is time, right? Time is moving, and let's say this is the true movement of the price of our asset. It moves up and it goes down and it goes horizontal and comes down back. Okay, so basically it's going up and down. And then these are the actions that we take, right? The first action, remember this action green means to buy, right? So here we buy, we sell, we hold, we do nothing, and we sell. So these are a sequence of actions based on what we observe here. So just take, for instance, this is the action we have to take based on this observation. So when we look at this, what action are we going to take? So our deterministic policy will just learn to take action. So when it sees an observation, it's going to take an action, right? So for example, I've just cut off this. If you look at this, I've just say, so this can also be an observation. Like you can see this is not at this point, right? I'm at this point. This agent is here, it's at this point. And it's seeing, it can see what happened in the past. It can see what happened here, here, and it wants to take a decision, right? So it looks at what happens and then it makes a decision. So we have a state. So this could be our state. Our state could be all the previous prices, right? And actions that we took. That can be our state. And then a policy. So our policy says based on the previous actions, based on the previous observations, right? Or based on the previous states, what action can we take? So we decide to buy, right? So if we look behind and we see this and we decide to buy, what do? We make money, right? So here we bought, right? We decided, okay, we buy. And if we buy, the price goes down and we lose money. Or if it goes up, we make money. So this is an example of a deterministic policy. So remember, a deterministic policy just takes actions directly, right? A policy at a given state will always return the same action. So anytime it sees this kind of state, it's going to produce the same action. So this is what this policy does. And then we have a stochastic policy. So instead of always taking the same action, it's going to give you a probability. So it's going to say, all right, if you buy, the probability of you making money is 80%. If you hold, the probability of you making money is 15%. If you sell, the probability of you making money is 5%. So this is a stochastic policy. So now you decide what action to take. So we can take this action based on, we can draw a random number and decide if the number falls less than between 5% and 15%, we take 15%. If it falls less than 5%, we take 5%. If it falls greater than 15%, we take sell, right? So we can take this action. This is what it means by stochastic. Like we can have, for this observation, sometimes we can usually have like this probability, but the action we're going to take is not deterministic. We can take any of these actions, right? So it gives us a probability of what action we can take, right? So like we can see here, we have a state, and our policy is given this action, what state? Given this state, what action do we take? So we take buy, probability of 80%, 15%, 5%, right? And so the policy is like given a state, what action do we take? So it's the probability of an action given a state. So what is the probability of buying given this state? What's the probability of holding given the state? What's the probability of selling given the state? So that's what this stochastic policy is about. So you can see now the difference between deterministic policy and a stochastic policy, right? A deterministic policy gives you the action you take directly, and a stochastic policy gives you the probability of the action that you should take, right? Okay. And then moving forward, then we can see that like learning, we already mentioned there are different learning approaches, right? We have value-based method and policy-based method. So let's look at the value-based method, right? The value-based method, like I mentioned before, it takes it takes an action based on the value, right? So it goes to a state where it has the best value, right? So for example, you can see here, I've tried to label all the states. So let's say we are coming from here and we are standing here. So our decision could be to take either this or this action or this action. So let's say that you see this one has the highest value, right? And we're going to take this, we're going to take an action to get to this state because this has the highest value. So that's the value-based method. So when we are here, we have the decision to either, if we buy, we go, this is what we are predicting. If we hold, we are predicting that it's going straight. If we sell, we are predicting that it's going down. So we can see here, the buy has the highest value, the hold has the second highest value, and the sell has the lowest value. So in value-based method, we want to take the action with the highest value. So we are going to go, the action that takes us here is buy. So we are going to buy. And when we come here, we have three actions that we can take. We can buy, sell, or hold. And if we buy, we go here. The same continues. If we sell, we go here. If we buy, we go here. So you can see the greens have the highest values. So that's where our actions are going to be. We are going to be taking actions that take us to the state with the highest value. So that's what value-based methods do, right? So in value-based methods, we learn a value function, right? So remember, like we mentioned, we are in reinforcement learning, we are learning in a function that maps states to actions. So in value-based methods, we are learning value functions. So this value function will give values to states and will decide how we take our actions, right? Yeah. And then basically this is explaining what we just did before. And then what is the learning process? So the learning process, we do exploration and exploitation. This is a very important another very important aspect in reinforcement learning. Exploration is kind of like you take wild action, right? Like sometimes what the policy is telling you to do, you don't do that. So exploration, let me just put it this way. If we take this, so sometimes you have a probability of 80% and you decide to just take 5% because you want to explore what will happen if you take that 5%, right? So that's exploration. Exploitation, you are always going to take this 80%, right? And then exploration and exploitation, we are trying to balance these two. In reinforcement learning, it's important to balance these two. This is a dilemma, and if you can solve this problem, you can solve probably most reinforcement learning problem. So taking this to explain exploration and exploitation again, we just know that to let's just say to explore, you're usually going to take this action, right? Not all the time, but you sometimes you take this action, sometimes you take this action. To exploit, you always be taking the best actions. So that's the breakdown I can give you. And then moving forward, so exploration. So this tries to explain exploration. So you can pause this to try to understand what I meant by exploration. So for exploration, you can see action 1, action 2, action 3. You can see that these actions are completely different. action 1, action 2, action 3. This sequence of actions are completely different from each other. And so it gives us like we are learning, like we are going through doing different stuff and trying to learn like what works, right? By exploring, doing different actions. But in exploitation, you can see, look at these three actions and you can see that they are very similar. So you can see the difference between this action and this action is just this, is just here. No, not here, it's here, right? This is the difference between this sequence of actions and this sequence of actions. The difference is here, right? And between this and this, what is the difference? The difference is here and here. So there's no real big difference between this action. So we can say we are exploiting. So we are just exploiting what we have learned. So exploration, this is how I can explain exploration and exploitation. And then so this I've already explained. So in terms of trading, you can in terms of day trading, exploitation and exploration, you can see that. So let's say that this is the green bar is the movement of the stocks. So these are just the values, and you want to explore and exploit. It means that you usually take values that are very close here. So when you're here, you can either take this value or this value. When you're exploiting, sometimes you take this, sometimes you take this, sometimes, all right. So, and when you're here, sometimes you take this. So for exploration, so you're always going to take, all right, when you're here, you can only take this or this. And when you're here, you can only take this or this. So you never reach here, right? Or you never reach up here. So that's the way I can break it down. It's not the best example, but that's how I can break it down for you. And then let's look at when you always hear like deep reinforcement learning. What is the deep in deep reinforcement? What does that mean, right? So we have deep learning. Deep learning is a branch of machine learning. Reinforcement learning is another branch of machine learning. And when we put this together, we get deep reinforcement learning. So we are using deep learning and reinforcement learning to do deep reinforcement learning, right? And this synergy of these two produces state-of-the-art decision algorithms, right? So deep learning learn to predict actions given a state, right? So in deep learning, we learn prediction. We learn how to predict given observations. We predict what will happen. Reinforcement learning, we are learning how to take actions that will give us the best rewards. So if we put this together, we get deep reinforcement learning, right? So we learn to predict and take actions, which gives us a decision-making system. So deep reinforcement learning is a decision-making system, right? And you can use this for building decision agents, right? So that's what deep reinforcement learning is. And you can probably use this for day trading. And then we have let's just show you the architecture that an overlay of the architecture of deep reinforcement learning, right? So we learn to predict and take actions given a state that will maximize our rewards, right? So you have an environment. This environment, let's just say this is a state, like we explained before. This environment produces a state. So at this state, we are going to use this state as input to a neural network, right? These states are input as inputs into a neural network. And the inputs to this neural network will produce probabilities of taking certain actions. So based on this state, the neural network will give us a probability of buying, holding, or selling. And we are going to use our reinforcement learning policy to take an action, right? So this is how we can put the framework of the architecture of deep reinforcement learning. So you have an environment, it produces a state. This state is used by a neural network to predict the probability of taking a certain action, and the policy takes the action. So if you're building a deep reinforcement learning for trading, so here we just have three actions, right? And they could be more depending on how you define your problem and what actions you want your agent to take. So this was just a quick overview of what deep reinforcement learning. It's not really quick because I think it's been really long, but I hope you've learned something. And I'm going to be bringing you a course that is going to take this step by step and will give you the theory and the practical. So we're going to use Python to build some deep reinforcement learning agents to trade in a real environment. So we're going to build an environment for it to trade. So what we are explaining here, we can do it practically, and we can teach an agent to make some profits, right? And that is what I'm going to be doing in the practical session. So this is just a quick overview of the course. This video is a little bit long, okay? And if you have please give me your comments and tell me what you think about this. I'm going to be putting on this material. I'm going to put it in a more succinct and way for the course to break it down step by step and to bring in a practical session where we really implement what we have just explained here. I know it's a lot to take in. This can serve as a quick overview for some people. This can serve as a starting step. This can serve as an inspiration. And I just hope that this inspired you to go deeper into deep reinforcement learning, either for trading or just learning the technology, the AI behind these decision systems. And all right, cheers, guys. I look forward to hearing from you guys, and take care.